Hey, this lesson is a chance for us to see if we can use those angle relationships that we learned in the last lesson. So let's take a look. In our diagram, we're asked to name a pair of vertical angles. So you might remember that vertical angles are when two lines have crossed to make an X, and we want to name those angles that are opposite one another. So let's see if I can highlight two lines in this diagram that have crossed to make that X. Let's take this line, JN, and this line, IN. Two straight lines crossing to make an X. Where are angles opposite each other in that X? Well, if we name the obtuse angles, we're right here and opposite right here. Let's name those two. We also could name these acute angles on the other side. I'll just show those, these two angles. So either one of these pairs would qualify as a pair of vertical angles. The obtuse ones are angle INM. Let's write that one down. Angle INM. And paired with that, angle JNL. That would be our second in the vertical angle pair, angle JNL. All right, next thing we have to do is name a linear pair. Let me clear this out. And a linear pair means that we have a line. Here's a line. Let's just use this one. We could also use the other straight line, one of the ones we highlighted before. Use this line. And I'm looking for a pair of angles that actually form that line. They need to be adjacent to one another. So the two that I'm going to use are right here. This angle paired with this angle. Notice how those two measures together are making 180 total, a half a rotation. So now we just need to name them. Angle JNI is one of those. So angle JNI. And the second one in our pair is angle INM. Notice that one of those is acute and the other one is obtuse to make the 180 total. JNI and INM. Okay, our next question asks us to name a pair of complementary angles. Remember, complementary is the set that adds to 90 degrees for its total. So I'm looking for two angles that are going to make 90 degrees together. And since these are adjacent, these are probably going to need to be angles that make a right angle. So let's see if we can highlight a right angle. I see one marked with the diagram in the little box that you see there at vertex N. So here's a right angle, and I can see that it's been split by the ray to make two angles separately. So the two angles we want to name that are going to be complementary are here as well as here together, these two. So let's name the first one INJ. Angle INJ would be one of our angles. Pair that with our second angle JNK. Angle JNK. And because they added 90 and make that right angle together, they are a pair of complementary angles. For our next example, our question is to name a pair of supplementary angles. What's our magic number on supplementary? That's the 180 number. So we're looking for two angles that are going to make a total 180, or in this case, because they're all adjacent angles, we want to look for that straight line. In other words, it's like a linear pair. Remember the definition of a linear pair. This goes right back to here. A linear pair has to be supplementary also. So let me re-highlight a line. Let's take this line for our example. And can I find two angles? I'm going to use these two angles here at the top for that linear pair. So here's my first angle, and my second angle is here. What are their names? Angle INM, angle INM with angle MNL. So angle MNL. Now there's certainly other linear pairs in here, and each of these, there's more than one answer for these. So you need to test yourself. Can you see if you've got more, or can you name more of the same type of angle? Last one is two sets of rays that are perpendicular. Perpendicular should remind you of that right angle right there. Remember the symbol? So let's name those two rays that are making this right angle here. And I'm going to highlight those. Here and here. These two rays are the ones I'm going to name. I also could come over here on this side, but I'm going to do the ones I've highlighted. So what are their names? Well, the first one is ray. Remember, our symbol for ray is that that single arrow. We always start at the vertex, which is N right here, and let's go out through I. That ray NI. And then using the perpendicular symbol, let's call it that perpendicular to the other ray that comes from N and passes through K. So it would be ray NK. And there's the names. Now we get to try to find some measures using the relationships we learned about. So let's take this diagram and let's just bring it down to the next question. You might want to, in your notes, recopy that diagram so you have some room. I'm sure yours has gotten pretty messy. Alrighty, here we go. We're given in this problem that angle INJ is 61 degrees, and we certainly are going to want to put that into the diagram. So find angle INJ. That's going to be right here, and let's label that a 61 degree angle. Now that's going to stand for the whole problem. First question asks us to find the measure of angle JNK. Angle JNK looks like we're right here on this little acute angle. How big is that? Well, the relationship we want to see is that that angle with our 61 degrees makes a right angle. So they're complementary angles. So if we want to find it, we would simply take 90 degrees and subtract out that 61 total for an answer of 29 degrees. Next question is angle KNL. Angle KNL is here. KNL goes from that point over. And we have to find what that answer is. Now, one thing you really want to remember is that if you have a right angle marking one side of a linear pair, since they add to 180, then the other side of that linear pair is going to also be 90 degrees. So that right angle, I'll draw that here. That right angle in one corner means that all the way around, all four of those angles are right angles. So this angle here that they've asked us is going to be simply 90 degrees. The next one is angle MNL. And angle MNL lies right here in our diagram. Now I'm doing this one in purple because I'm noticing that that angle MNL makes a vertical angle with the 61 that they gave us. And we learned that the relationship between vertical angles is that they are congruent. Let me tick mark those and put 61 degrees here in my picture. So angle MNL would be 61 degrees. On our next one, we've got angle JNL. Angle JNL is bigger. It's going to have to come all the way from this ray clear around to here. So angle JNL is made up of these two angles. Did we ever figure out what this angle was? We did, but we didn't put it in our picture. That was our answer to A. That was our 29 degrees. So let's use our 29 degrees, and then this angle right here is 90. And we can just add those two together using our angle addition postulate since those are adjacent angles. So this angle would be simply 29 plus 90 degrees for a total of 119 degrees. So that's angle JNL. And finally, angle MNI. Angle MNI goes here. You'll see I'm doing these with the same markings because, again, this is another example of vertical angles being congruent. These two angles, the one we just found, as well as angle INM, are vertical angles. So they are the same, and this would be the same answer that we got just a minute ago, 119. 119 degrees there. Now our next example has some algebra involved, but number one, this is geometry. We need to find the value of the variable, which is going to require us to set up an equation, which means we need to know the relationships that these two angles have. So let's go ahead and mark those two angles. The 63 degree angle lies across from the angle marked with our expression, making them vertical angles, and they are congruent. Congruent meaning equal measure. So my setup in this is going to be simply to set them equal to each other. So I'll say that my 11y minus 36 is equal to the 63 degree measure. Then I just have to solve for that y. So first I will add the 36 to cancel it from the left side. And that leaves me just 11y equals a total of 99. Finally, I'm going to reduce that 11y down to 1y by dividing by 11. And so my final answer for y is 9. And that would be the value of y. In this one, the same thing applies. We have to find our variable. What's our relationship between our angles? Well, these two angles are together making this straight line here. So they're going to be supplementary and add to 180 degrees. My first angle, my acute angle that I don't know, combined together with my 137 makes a 180 total. Let's set up an equation that says that. We would take the 4x minus 17, that's angle number 1, and add that to 137, and then the total, all together, those make 180 degrees. All right, here comes the algebra. So this minus 17, that's a minus there. This negative 17 combined with the 137, if we add them together, that's going to be a positive 120. Bring down the 4x and the equals 180. Let's subtract to cancel out the positive 120 from both sides. And that gives us a new total of 60 equal to 4x. Finally, we're going to divide by that 4 to reduce the 4x's down to just 1x. And 1x is 60 divided by 4, which is 15. So the value of x would be 15. And just for the sake of showing your work here, let's show that that really works. Plugging in the 15 for the value of x, 4 times 15 minus 17 gives me 60, minus 17 gives me 43. Does 43 add together with 137 to make 180? Well, if you check, you can see that it does. So that's how you use those properties of special angle pairs that we've learned.